Good afternoon, all of you. In the previous class, we discussed about enthalpy, the total heat content of a system, and we derived some relationships between change in enthalpy and change in internal energy with respect to inert gas, solids, and liquids. So that's what we studied yesterday, and today we are going to study two new terms which are extensive property and intensive property. So we should know what is an extensive and intensive property and what is the difference between these two properties. So first we will see some example for that. Imagine you are tasting a spoonful of sugar. So how the taste will be? It will be sweet in taste. And now you are asked to eat a full sack of sugar. So how the taste of sugar will be in this case? There also it will be sweet in taste, right? So in the initial case, you took a small amount of sugar and tasted it, and then you ate a bigger quantity of the same substance and tasted it. Both the cases you got same result or same taste. So taste of sugar does not depend on how much we take it. And another example, we are taking some amount of gold particles and we are trying to melt it and find the melting point of gold. And after some time we took a bigger quantity of gold and then also we are finding the melting point of this. So in both the cases, will there be any change in the melting point? No, because melting point is a property where it will not change with the quantity which we take. Another example is if we consider hardness of both of this, will there be any change of hardness for gold in this case and this case? There will not be any change. And one more factor is color. So if we take a few amount of gold and big stones of gold we are taking, both of them will have same color also. So one more example is, consider a glass of water. We are measuring the density of this water. And now after finding the density of water in the glass, we are taking a big full bucket of water and finding the density of the same water. And we should consider distilled water in both cases. So if distilled water we are taking, even if it is in a huge quantity or if it is in a smaller quantity, will there be any change of density between those? There will not be any change at all. So here we have an iron dumbbell and I am finding the mass of this dumbbell and comparing the mass of this dumbbell with another bigger dumbbell. Will that be same there, or will the mass of this dumbbell will be same of that of the bigger dumbbell? No, because they are of bigger size. So this dumbbells are of bigger size than that of this. So if it is made of same material, then we can tell the smaller one will have lesser mass and the bigger one will have a bigger mass. So mass, when we tell, we have to compare the quantity or the amount what we have. Another example, as I told before, I am considering a full bucket of water and I am finding the volume of this water which is present in this big bucket, and I am comparing that with a small glass of water. So is that comparable or is that same? No, because the volume of this much water will not fit into this glass. So this is not same. So volume also depends on the amount of substance what we have. So in one side we have seen some properties which does not depend on the amount or quantity of matter which is present. Even if it is in a smaller quantity or if it is in a bigger quantity, the property shows the same. In the other side, we have some kind of properties which totally depend on the amount of matter what we have. So the type of properties where it does not depend on the quantity of matter are known as intensive properties like taste, hardness, melting point, color, density, etc. And the other type where it depends on the amount of matter which we have are known as extensive properties like mass, volume, etc. So this side we have the intensive properties which does not depend on the quantity, and this side we have the extensive properties which depend on the quantity or amount of matter what we have. So we will see what definition we have for both of this. An extensive property is a property whose value depend on the quantity or size of matter present in the system. So those type of properties are known as extensive properties. For example, we have mass, volume, internal energy, enthalpy, heat capacity, etc. So these are the quantity or these are the properties which depend on the quantity or the size of matter. And those properties which do not depend on the quantity or size of matter are known as intensive properties like temperature, density, pressure, etc. Now we are going to do an experiment related to this. For that we need a hollow box or an empty box in which we have just air inside it. So we are considering an empty box in which we have air in it. And the volume of air which is inside the box we are considering it to be V, and the temperature of the gas to be T. So as we know, volume is an extensive property which does depend on the amount of matter, and temperature is an intensive property which does not depend on the matter or amount of matter. So that we are going to prove here. So initially the volume of gas present inside the box is V and temperature of gas is T. Now what we are going to do is we are going to separate this box into two. So when we partition the compartment into equal two halves, will there be any change for the volume of gas and even the temperature of gas? Volume of gas will change because it depends on the amount of gas present inside. So volume, initially it was this much, so big it was, and when we cut that or partition that into a half portion, volume also reduced to its half. So the volume initially if it was V, final volume will be V by 2 in both the compartments. Initially the volume was V, and when we partitioned it the volume becomes V by 2 because we made it into half. But what about temperature? Will there be any change for the temperature? No, because if we partitioned it or if it is together also, there is no change for the temperature. So if we want to change the temperature, then we need to supply heat or we need to do some work inside the system. That and all we are not doing. We are just separating the compartment into two. So temperature will not change at all. So the only quantity which changed here is the volume. It changed to half. So this is the difference between extensive and intensive properties. Extensive properties changes with the amount of matter which we are experimenting, and intensive properties like the temperature will not change if we change the amount of matter also. So from this we proved that volume is an extensive property and temperature is an intensive property. And now we will see another side of extensive and intensive properties. For that we are considering a system with volume is equal to X and its molar volume is Xm. So volume is X and molar volume is Xm, or we will see what is the difference between X and Xm. This we have learnt in states of matter. So X is the volume, or for a matter how much ever space is needed to occupy, that is known as volume, and molar volume is nothing but volume required for 1 mole of substance to exist. So volume is the space needed for the substance to exist, and molar volume is the space needed for 1 mole of substance to exist. So that is the difference between these two. So molar volume is represented by volume by number of moles present in it. This and all we have learned in states of matter. So the fact here is X, or the volume, we can tell it's an extensive property as we told. But when we divide this extensive property with a particular number, it becomes an intensive property. So here the volume, or the X, depends on the quantity of matter which we take, and Xm, or the molar volume, does not depend on the quantity which we take. We will see that by an example. For example, in a class I have given 10 rupees with few students, and we have two terms here, which is T and T by N. So T is the total amount which I have distributed, and T by N is the total divided by number of students. So it is similar to that of volume and molar volume. And I am telling that T is an extensive property which depends on the quantity or number of students I have, and T by N is independent of the student number. How is that? We will see. So T is the total number. If I am increasing the number of child, then T will change, because the sum of this will change. 10 plus 10 plus 10, it will be 30 for T value. But T by N, when there were 2 students, T by N value was 20 divided by 2. So it will be 10. And when the T by N in this case will become 30 by 3, then also we will get the value same as 10. And one more student I am adding, then what is the value of T? Now the value of T has become 40, because there are 4 students. But what is the value of T by N? It still remains to be 10, because it is 40 divided by 4 students. So this is somewhat similar to that of volume and molar volume. We are just considering the average, or when we divide it with a number there, we get almost same value, or this term is independent of the number which we have. So this is an extensive property and this is an intensive property. This depends on the amount which we have, and this does not depend on the amount what we have. How much ever we increase the amount or quantity of matter, this will not change. This will be a constant value. So if we consider the real example of volume also, we can understand this. So if I am considering a beaker full of a liquid, and I am thinking that 1 mole of this liquid is this much. So molar volume of this liquid means how much is the space needed for this much of liquid, or how much is the space required for this much of liquid to exist. That is molar volume, and volume means the whole amount. How much ever we take, that is the volume. But if we increase this volume to double of it, if I am taking it in a big beaker, the volume might change, but the molar volume remains the same, because this much is the molar volume. Even if we take a bigger container or a smaller container, 1 mole or 1 mole existence will be in same amount. So this is the difference between intensive properties and extensive properties. So concluding, at some point of time, extensive properties are converted to intensive properties when they are divided with some number. So that's what we told here. For example, molar volume and molar heat capacity, etc. So when we speak in moles, the extensive properties are converted to intensive properties. So extensive properties are converted to intensive properties when we consider their molar quantity or molar property. That's all about intensive and extensive properties, and now you can classify this into extensive and intensive properties and include that also in the notes. So with this we conclude our session. So read the textbook well and prepare notes. Thank you.